Today we're going to be talking about the Autel mission planner that is found in Autel Explorer. Now, before I get started, I want to point a couple of things out. The Autel Explorer system is not designed to work with aircraft such as this is the Autel Evo Lite, which is similar to the Nano. It's one of the newer offerings that they have. So this is the Lite. It's just a little bit smaller than some of their other units. So this is the Evo 2 Pro with the dual camera on it. So you can see that it's a little smaller aircraft. This has a completely different battery setup, etc. So this aircraft does not have any automated mission planning capabilities at all. This is more designed, the Nano and the Lite series are really more designed for the hobbyist, people that are looking to take great photographs. It does have the same camera as the Evo 2 Pro. But it is not designed for missions and doing mission type work. So if you've got something like the Evo 2 Pro, Evo 2 Dual, 640T, the Evo 2 8K, which is this unit, here, these all take advantage of the Autel Evo Explorer or the Autel Explorer app, which you can see running on the tablet right here behind me. And in fact, we're going to be running off of this tablet right now. So I'm going to go ahead and get right into sharing the screen. And what you're seeing will match identically with what's on this tablet here. For those of you that are asked that may ask, I'm using a tool called Visor, V-Y-S-O-R. Visor is a tool that allows you to take any Apple or Android tablet device and plug it into your computer and visualize it. So this is how we're able to send this information out directly over Zoom or any number of different applications. So although I'm working on my computer desktop, all of those changes will be reflected live in the tablet behind me. So you'll see those things happening in sequence. So when we very first power up the Autel Explorer application, this is the screen that we come to. And we have two screens to work with. We can work with the camera screen or the mission screen. Today, we're going to work with the mission screen. So we're going to tap on mission, and this brings us into the choices of missions that we have. We've got 4 different mission types that we can select. We can select a waypoint mission, a rectangular mission, a polygon mission. We can also move over here and grab an oblique mission. And then last but not least, it's got this recording function that will record the mission as we flew it. Straight up, I'm just going to tell you to entirely ignore this oblique mission tool set that's right here. Why? Well, the oblique mission tool is, I mean this with all due respect to Autel's engineers, but it's very badly planned. And if you use this particular format, what'll happen is you'll end up with significantly more images than you want to, because what it does is it tilts the camera at an angle and it flies the same mission area effectively 4 times. So it takes nearly 4 times as long if you use this oblique mission mode. Its name is confusing and its use is even more confusing. At the end of the day, let's say that you do use it and you come up with all these extra images. When you drop them into a tool like Pix4D Mapper or into Leica Infinity or 3D Reality, some of these different tools, because there are so many repeats of the same pixels and similarities in the lat long data or the GPS data that's embedded in the metadata of each photo, you're going to increase your errors. So you will not have a measurable result at the end of the day. So I wanted to point out, we're just going to ignore for this session oblique entirely. So let's get back over here and look at the 2 most common missions that we're going to use. The first one is rectangular. So when we click on this, it opens up. We can see what that mission looks like there. And we can zoom in on the mission here. You want to be careful on a desktop as the zoom is indeed pretty deep on the desktop. So in many cases, I'll turn and use my tablet because I get a little bit more finite control when we use the tablet here. So there's a couple of different ways that we can work with all of this. One of the things here is if you get lost, if you do what I've just done and you can't find your location because you're zoomed in too deep, we can either search for a location or we can tab on the locate button and we're going to choose me. And this, sure enough, it drills us in pretty deep into where we want to go. Now, I have a vacant lot across the street here where they're preparing to do some construction. So I'm going to go ahead and zoom in just a little bit. And like I say, you're seeing that happen in real time on my screen here. One of the tips I'm going to give you straight up is before you begin planning your mission, zoom in fairly deeply into your area. Why? Because when we hit this create project button, it's going to limit the scope or the size of that particular project. So I've located this vacant lot right here where construction is about to begin. And what I want to do now is I'm going to create a mission. So we're going to tap on create project. And as soon as we do, we get these indicators right here. So all we need to do is grab on these little arrow pieces right here and drag them to the position where we'd like to work. Now, this vacant lot is the area that I want to capture, and you can see the fence lines fairly clearly there where this lot's property boundaries are. However, this is not what we want for a mission. We need to expand that area by about 20-ish%. So I'm going to come out here. I'm going to increase our area, and you can see that I'm doing that off to the two sides. Here, I'll come off to the side and then drop it down just a little bit more. So we want to have at least 10% offal, or in other words, over area, so that we capture all of these areas, these edges that we see right here cleanly. Now, if we have a windy day, or if we've got things in the way, what we might want to do is increase that just a tiny bit more. So here I'm going to make it just a little bit bigger than what my need is. Yes, in this particular case, we are getting over top of some private property. Legally, we're entirely entitled to do that. Ethically, you may or may not want to have a conversation with property owners before you fly over their home. You're each going to know your particular township culture better than I'm going to. Here in Las Vegas, we often will notify neighbors, hey, there will be drone operations. We also put a sandwich board out so that people understand that there are aerial operations that are taking place, and it just really helps calm down the neighborhood a little bit. But so here we've created a basic mission. Now this is rectangular only. It's the only shape that we can work with. So in other words, if you need a mission that is not square or not rectangular, this mission profile will not work for you. So this is the remainder of the parameters are exactly the same. So we're going to move into a different type of mission. So I'm going to come up here and click the red A in the upper left-hand corner. In this case, I do not want to save my mission, and it takes me right back to home screen. We'll tap on mission again. This time we're going to choose Polygon, same basic area that we were working with before. So we're going to zoom in just a little bit, and that zoomed in way too much. So I'm going to come back over to my tablet and zoom out just a bit. So I can get back to my mission area. And again, if we've lost our space, we simply need to click that arrow up in the target up in the top, choose me. This gets us back to our area. We'll zoom in a little more deeply. Now this time I'm not going to zoom in quite so deeply, because what I'm going to do is, instead of just this one vacant lot, I want to capture this entire area, because these are an area of full development that's going to take place. So I'll show you what I mean by that. Let me close down this notification. So we're going to create a project. Here's our project parameters. We're going to go all the way out here to the street, and then come all the way down here also to the street. Remember, we're looking for a little bit of overage. We're going to do the same thing here. We can bring this down to this area right here and come up all the way up here. Now, we've got two private residences in here that we don't want to capture, and there's different pieces of them that we don't want to capture anyway. They're not part of our mission. So if we tag the little plus sign that you see right here, now we have some control over our area. So I'm going to take this corner, pull it into right about here. I'm going to take this corner and pull it into right about here. Let's even those up or clean those up just a little bit. There we go. Now what I'm going to do is tag this plus sign up here, drag this down here, and I've carved out this area. Now I'm going to do the same thing here. So I've got a little carve out there for that home. I'm going to tag that one more time and drag this up to this corner, and then drag this one over here and drag this one over here. So now we've got the entire lots that we need to capture in the area here. And this is giving us the ability to overshoot just a little bit. We might want to adjust that slightly bigger here. Now at this point, we've got our mission parameter area set up. Let's get an idea of what that mission means. Well, currently, with the way that the mission is set up, we're going to take 3 minutes, 52 seconds, so basically 4 minutes to fly this mission. It's going to capture 58 images. Well, that means that mission is planned fairly high up in the sky. So we're going to come down here to this button that shows the mission plan, and we're going to tap it. And this allows us to change up our mission. Now, currently we're at 60 meters. That's pretty high. So in this particular case, I'm going to bring that mission down more like 27 meters thereabouts. So this has got me a little closer to 100 feet in altitude. What I'm looking for is I'm looking for a GSD somewhere between 0.3 and 0.5 centimeters per pixel. In this case, I'm at 0.46, so that's pretty close to my target area. So, what is GSD? Well, GSD stands for ground sampling distance, and it is the difference of taking your cell phone and taking a picture of someone and walking up close to them or walking far back and then using a zoom lens to zoom in. We know that when we use the zoom feature, we lose resolution. Well, it's kind of the same thing here. If we fly very high and try to adjust that altitude in post, we're going to see our pixels get bigger. Now, if all you're doing is straight ahead ortho and you're just looking for a flat map that has no measurability or no precision requirement for measurability, hey, fly that as high as you want, it'll fly pretty fast. On the other hand, if you're looking for precision and you need to be able to measure down to those very small few centimeter levels, you want to fly that mission as low as you possibly can within reason. And within reason means is this going to be a one battery flight, two battery, three battery flight? Well, in this case, we can see with this adjustment in altitude, we're now an 8-minute 38. So we'll call that a 9-minute mission. It's going to be 245 pictures because it's fairly low, but it's right there with what we want for our GSD. So it's hitting in the perfect marks. Now we're going to adjust our speed down just a little bit. Instead of flying at 18 miles per hour, let's fly this somewhere around the 12 to 14 kilometer per hour. In this case, I'm looking at kilometers per hour. We can adjust this to be miles per hour. We can adjust this to be feet per second. So we have a lot of different ways that we can determine our flight speed. Whenever we're flying fairly low, we always fly slow. When we're close to the ground, those pixels are moving past the camera pretty quickly. And so we do want to slow the drone down to get the very best image we possibly can. Now, keeping in mind that all of the Autel cameras are rolling shutter cameras. So if we fly slow, we get the same type of output as if it were a global shutter camera. Yes, if it were a global shutter camera, we could fly a little bit faster, but it's never a guarantee that you're going to have a great mission. So low and slow. We're flying at high altitudes over 120 feet for very large areas. Fly it as fast as you'd like. 22 miles an hour is the peak speed I ever recommend under any circumstances. But just be aware of what that is. So let's move on to other menu choices. Here we have overlap. So when we're dealing with overlap, there's a couple of different ways that we can view overlap, but the easiest way is to illustrate it this way. So we have an image, and in order to assemble this image with the next image, we need to not butt those images against each other, but rather overlap those images. We have two types of overlaps. We have a side lap and we have a front lap. We need to be able to stitch those images all the way around the circumference of that square. And so in order to do that, we're going to set up our overlap so that our tools like Pix4D, like Infinity, Bentley, whatever tool you're using in post-processing are able to lay those together. Because what ends up happening is not only do the good softwares, and I mention good softwares because there's free softwares that don't look at both lat long and pixel data. When we use a good software like Pix4D Mapper and Bentley and the Leica software family, the software application is looking for the latitude, longitude information that's embedded in every single picture, but it's also looking for pixels that can be matched up. So if we've got a good overlay, then it makes it a lot easier for our software tools to generate that match. So let's get back to our screen here. All right, so we've set up our front overlap. That's this overlap here, and we're at 80%. That's an important overlap because that's where the drone is moving from place to place and it's hopscotching itself, so to speak. Then we have our side overlap, which should be somewhere between 70 and 80%. The lower we fly, the higher this needs to be. So in this case, because we're flying fairly low, I'm going to set this up to be 80%. Now we can either select this by tapping on it and moving the slider and shifting the value there. And if you look on the left-hand side of the screen, you saw this value change. It's now at 80%, or we can double tap that number right there. And by using our computer keyboard, we can erase that value and input a new value. So here we're going to go to 85%, which is done. Now it's an 85% side lap, and we're ready to move on with that. So pretty simple in adjusting these different levels. Next, let's go to our gimbal pitch. Now the gimbal pitch is always by default set at 90 degrees. That means that the camera is looking straight down at the ground. This is also referred to as nadir shots, and in other words, looking straight down at the ground. If you are doing typical orthos and you're just looking for a flat map, we want this at 90 degrees. If we're going to be adjusting this, or rather using this map for a model as well, we might want to consider adjusting this gimbal pitch. Instead of shooting at 90 degrees, I'm going to set this up and shoot at 75 to 80 degrees. So in this case, I'm going to choose 80 degrees. And what that's going to do is pitch my gimbal just slightly forward. And that allows me in a top-down only flight to capture a little bit more 3D data. So if we're looking at building out contours, if we're looking at building out various things on a job site where we're preparing for earthworks and moving dirt or volumetric calculations, we can get away with an 80, 85 degree angle pitch. And it'll give us just a little bit more information. But if we're going to be combining this with other kinds of flights, such as oblique angular flights around the mission area, we'll set that up straight at 90. Let's move on in our menu. Next, what happens when the mission is done? Do we want to go home or do we want to hover? If we're going to fly only a nadir mission that's going to be used for an ortho mosaic, a flattened photograph, go home is our normal choice. However, if we're going to be doing some manual picture capturing, maybe you're doing progress reports, site reports, or just simply other site updates, instead of having it come home and land, let's have it hover, and then we can take over manual control of the aircraft to get what we want. Next, in the menu, we have go home. What happens if the remote control and the drone lose connection? Do we want the drone to go home or do we want it to continue the mission? Generally, resume mission is the preference. Next up, we have let me just get rid of my keyboard here for a second. My keyboard is not going down on me, so work it this way. And for whatever reason, my keyboard is staying stuck open. All right, well, we'll just deal with it for now. All right, so what'll end up happening from here is we can see we've got an 18-minute, 38-second mission. Okay, well, when we go back in here and we set up our course angle, it may be we need to shift this course angle because of wind. It's not going to lengthen our mission by much. So for example, here in Las Vegas right now, our winds are blowing hard north to hard south. And currently our mission is flying hard east to hard west. We generally want our aircraft at an angle to the wind. In other words, so that one of the arms of our aircraft is pointing into the wind. What this does is it sets it up so that when we're in a crab wind scenario, we have equal pressure from the wind on both sides of the aircraft during all periods of flight. This means that our aircraft is never moving any faster in one direction or the other. If we fly directly into the wind, we're always facing a headwind, which slows the aircraft down. And if we're flying away from the wind, we're in a tailwind, which speeds the aircraft up. This is a guaranteed failure for your mission. Your mission will always fail if you are flying head tailwinds. That's just something that we don't want to do, is fly into those headwind, tailwind scenarios. So we can also set this up for an auto course correction. I generally don't do that, so I'm going to go ahead and leave that in this mission. Next, we have close. This is a double grid. And what this means is if we're going to be flying for modeling, we want to open this up, and you'll notice that it creates cross hatching. All of a sudden, we're at 38 minutes, 50 seconds. It's 930 images. So we've just doubled our mission time. I'll only turn that back off. Here we're at 480, 19 minutes. If we turn that on, we're at 38 minutes and 930. This will double up your data, but this is how we get the beginning of good 3D models, is by setting up that dual grid right there. And that brings us through to the end of the actual mission planning component. So I'm going to close this down right here. And the next thing that you notice is that we have this blue button that's shown up to the side. Now, this blue button currently isn't going to be doing anything for us because we don't have an aircraft connected. But if we had an aircraft connected, we tap the blue button, it's going to come up and it's going to give us a mission knee board or a checklist. Is there a micro SD card? Is the IMU in good shape? Are the motors in good shape? Where is that data going to write internally or externally? It goes through a safety check for the aircraft. And then at the bottom of that, we have a tap fly button. That means that the aircraft will take off. Generally, that's not how we operate our missions. Generally, we will set up the mission, lift the aircraft into the air, do a safety check with the aircraft by checking all control surfaces, and then we tap the blue button, which will upload the mission while the aircraft is in the air and start its flight. And this way, we are able to accomplish our safety checks and also, set up our mission for flight. So that's the first step in getting any of this overall set up. Let me click my back button there. There we go. Finally got rid of that keyboard. Took a few clicks. All right. So other things that we might want to change in our overall mission. Well, first thing is we want to save that mission. So we're going to come down here and click the save icon. And we're going to call this Mason Corp pre-flight. Now I've saved this off. So now that I've saved the mission off, I can recall it at any time, any point in time that we want to. Now we've gotten back to this screen right here. This is where a lot of folks get lost. We may have decided once we arrive on site, so we planned this mission away from the site. We arrive on site, we discover the wind's not doing what we expected it to do. We're going to come over here and hit the edit button. And in the edit button, it calls up our edit features all over again. And while we're here, we're just going to go ahead and adjust our course angle just a little bit more here. Now, the question was just asked, what wind speed should be considered the limit when doing a mission like this one? Well, generally, although the Autel Evo 2 is what we call a Beaufort 8 drone, it'll fly in 50-mile-an-hour winds, but it will not fly a successful mission in 48 miles an hour or 50-mile-an-hour winds. So 30-mile-an-hour winds should be your peak. And what we're really looking for is constants, not gusts. If there's a big delta between constant wind speed and gust speed, wind gusts, chances of having a very successful mission are pretty slim. So if we're seeing constant winds of say 15, 18 miles per hour, but we're seeing gusts of 30 miles per hour, that's probably not going to work very well for you and your aircraft. But if we're seeing constant winds at 25 miles per hour, you're good to go. If those gusts are only 28 to 30 knots, so it's not a big deal at that point. All right, a couple of other things that we can do here with our mission overall, or things that we might want to look at with our mission here. So as we get these set up here and we close these missions down, we can go back up here to this planning window. So we tap on the A again, go back to mission. Now there's our pre-flight that we've set up right here. But let's go over a couple of other missions. So if you've got a lot of missions saved, maybe you're returning to that job site every week, we can use the search feature and go find the mission based on name. Additionally, here we can tap in and we can look for different missions that we might have on our system. So it may be that you've got a KML file that you saved off from Google Earth and you want to store it here. We can import a KML file. So that's what that's for. Here we have the ability to view all of our missions in a grid format. We only have one mission saved in on this tablet, so it's not really useful for what we're trying to achieve here. But this is how we're going to set that piece up. I'm just about out of time here. So I'm going to just kick back to my mission. Let's reopen this Mason Corp pre-flight. Maybe we're returning to the site another day and we want to fly the mission again, but we realize we're capturing too much data down here. So we're going to edit this mission. So let's go into our edit mission mode. You'll notice everything here turned blue. This means that we can now click and modify our mission per our needs. So it may be that we only need to fly a small portion of the mission again. So now we've edited this, we can indeed save this mission again, just like this, and that allows us to save that route again. So it's pretty easy for us to go through and work with each one of these two pieces here. If we click on the pencil, this allows us to rename the mission. One of the questions that just came forward is, what do I set if the battery gets low to return to home? Do I need to do that? Aaron, that's a great question, and one that doesn't show in this particular mission planning app. But what'll happen if you have a mission that needs multiple battery changes, that's no problem. What will happen is the Evo 2 will return back to its landing point. It will land. You're going to turn off the battery, remove the battery, put a new battery in, turn on the battery, and the app will come up and say resume or abort mission. All we do is tap resume. The aircraft will go through its safety checks again, and then it will take off. It'll fly back to nearly the same point where the battery expired. It'll actually go a little bit back in time. So you're going to end up with 2, maybe 3 photographs that are duplicates because it would have already captured them in that site, and it will resume the mission. Now, I've never tested this beyond 12 battery changes, but we have tested it all the way out to 12 battery changes. Some of you may have seen the big 77-acre helicopter fatal crash that we flew last summer, Brady Reich and myself. That was 12 battery changes each, and everything worked flawlessly. So I don't know what happens when you get past 12, but I can tell you we have done 12 battery changes individually. So we're just about out of time here. If there's any questions that you folks have, I can answer them for the next 2 or 3 minutes before we wrap up the session. While you're thinking of your questions or getting ready to input them, I'll share with you that next week, we're going to be looking at LiDAR outputs from the microdrones MD-1000HR and how these can be incorporated into standard and precision workflows, whether you're working with construction for earthworks or you're working with a survey company to make decisions about contours and so forth. So we're going to have Brady Reich presenting that program next week. We're really excited for that one. We've had some really interesting survey flights that we've done, particularly up on the Columbia River. One of the questions from there, Lewis, good question. Can you import a DSM model? No, sir, you cannot. This is merely a planning surface, and DSMs it does not have support for DSM. So KML is the only thing that you can import or export from this application. Bearing in mind that you're seeing me work with this on the laptop, or rather on the desktop computer that's here, that's only because I'm using a tool called Visor, which is the direct interface between my tablet and the computer. It just allows me to control my mission on the computer, which is a little bit easier, a little bit more precise than it is doing it on the tablet itself. Does the mission planner tell you the distance between passes? And if you're going east on one pass and back on the next, can you know the differences between the 2 passes in north-south direction? It does not indicate that, Andrew. You kind of have to self-figure that out. Some of the older tools like Mission Planner, for like QGC or for Pixhawk tools, they will give you that spread or that delta, but that doesn't happen in most of the other applications. All we get is the total area that we're flying. So here we can, when we look up here, we can see that we're flying 12,241 square meters in the flight, but it does not give us the path. One thing that it does do, however, is the camera data. And part of the reason they don't give you this is because the camera data is already input into the application, and it knows what the field of view is going to be, and it automatically compensates for that. So this is not like some of the older mission planners where you had to calculate that field of view from the camera at different altitudes. It does automatically configure that for you. So if you look at the passes right here where we're flying at 100 feet, we take that same data. Let's go over here and change our altitude up a little bit. Whoops, we don't want to go that far. Here we go. So here we're at 65 meters. You can see here how it automatically adjusts the width of those paths, those points of overlap or points of path. So it widens them up because the camera is able to see more. One of the questions just come in from, I need to share my screen back again here. Thank you. There, now you can see those wider overall lanes. So again, if we take that and we reduce it, you're going to see those lanes get very narrow. When we get down here fairly low, so there's a 35-foot flight. Holy cow, that's crazy. The fastest it can go here is about 1.5 miles per hour, so it's not going to fly very fast. And look at what happens. We've got very narrow lanes because the camera's down low, and that's a 63-minute flight. That's easily a 2-battery flight, of course, and 3,200 or 3,158 images. One of the questions is, can I change the start and end points? In this particular system, we are unable to change those. That's a request we've made several times from Autel. But that does bring up a really good point that I want to address here, is that when we are setting up this mission, you'll notice we've got a long distance right here and a short distance when we're right here. This mission, I'm going to choose to control from just right about here in my mission area, because that gives me the shortest distance to this corner, shortest distance to that corner. But it would be a really nice value if Autel would give us the ability to change up the start point, end point, much like Data Pilot and QGC, some of the other tools out there do. We'll continue to work with this. The question is, would I also be doing orbit shots for my 3D? Yes, and orbits are what we refer to as obliques. If I'm going to do that, what's going to happen is I'm going to get out of this mission planning mode. I've told it that at the end of the mission, I want it to hover. Once that mission is done, now I'm going to go back to my front piece. I'm going to go to camera. We'll shut this down because we don't need it. And in terms of what we're going to do next is we'll go up here to manual flight, and we're going to convert that into either a smart orbit or a standard orbit, and we'll adjust our camera pitch accordingly depending on the altitude of flight. One tip I'll give you is when you're setting up your orbits, make sure that your camera is never seeing sky. You never want your camera to see sky, whether you're working with Pix4D or Bentley or these other tools. It can become really confusing. So we want to avoid that. This brings us to the end of this session. I realize it's a lot of data to try to present in a lunch and learn, a 20-minute section. My email address is really easy. It's Douglas, D-O-U-G-L-A-S, at Krinc, K-R-I-N-C, or krinc.net. And our moderator has put that into the chat box. So if you look at your Zoom chat box, you'll be able to see that. So again, really quickly, you'll want to be sure that you catch up with us next week, where we're going to have Brady Reich taking us through and talking about outputs from the microdrone system. We're also then the week following going to be on April 27th, having an overview of the Leica CS30 field controller. That's going to be Matt Kowalski driving that. We're really excited to have Mac present a session. He has 25 years in the very high-end concrete profession and has been using scanning gear and drones for a long time. Mac is one of the most knowledgeable and exciting people that I've ever had opportunity to work with. So thanks for being in with us this week on the Lunch and Learns. We truly do enjoy having you around. We know your time is valuable, and we want to be sure we're giving you good value in exchange for your time visiting us. So until next week, I'm Douglas Spotted Eagle with Kuker-Ranken, and we look forward to seeing you at our next Lunch and Learn. Take care, everyone.